Well, thank you all for coming. It's always fun to have the chance to join with all of you in reflecting about epidemiology and the history of the field. I've now given several of these talks, and I thought I had reached the limit of new topics I could share with you. But then this summer, like many people, I got preoccupied by the problem of heat and the heat waves that afflicted not just Boston, but many places in the world. And this was actually something that I had worked on briefly in graduate school. So it was fun, as you'll see, a bit disappointing to come back after 25 years away from a topic and see what has changed and what hasn't changed. So over the past summer, if you believe the current reports, it looks like populations in the Northern Hemisphere have dodged a bullet. India and Pakistan were hit first with a tremendous heat wave in April and May, with temperatures as high as 51 Celsius, 123.8 in Pakistan. The highest wet bulb temperature that was reported was 32.5 in Chennai in the south, not far from a wet bulb temperature of 35 degrees, which many experts predict is the threshold for human survival. But despite this record heat, the Indian government has reported just 90 deaths so far. Everyone assumes that's a vast underestimate, but it is an indication that there was not yet a major mortality event related to this heat wave in South Asia. Heat waves recurred throughout the Northern Hemisphere all summer in the United States, in Europe, and in China, also accompanied by droughts and wildfires. And yet, as far as I can tell, there have been no major reports of mortality associated with this heat wave in any of these countries over the past 2 or 3 months. And this raises an interesting question. Physicians and epidemiologists have long known that heat is the leading cause of weather-related mortality. Heat waves have killed tens of thousands of people in the past. And you might have predicted that there would have been severe mortality with the heat that many countries in this world experienced over the summer. But that does not seem to have been the case. So it raises the basic question: what are the factors that determine the impact of a heat wave? And this, it turns out, is one of the most ancient questions in medicine and epidemiology. People have been wondering about this for thousands of years. So I will briefly review that history, focusing on the specific issues that persist as challenges for epidemiology today. And I hope that this history will help us think about prospects for the future as the Earth continues to warm. Now, as I had said, concern with heat is ancient. The Old Testament includes a story about an overseer who died from heat during a harvest. Anyone who has read Airs, Waters, and Places will recognize that Hippocratic physicians advised physicians to pay close attention to winds and to heat. And with proper care, they advised the ancient Greeks and travelers that it is possible to adapt yourself to a new climate. Heat was a major concern for Europeans as they colonized tropical regions on Earth from the 16th century through the 19th century. James Lind, who's usually known for recommending lemon juice to prevent scurvy, was actually most famous at the time for his work on the diseases of hot climates. And this remained a concern throughout the 19th century, especially in the United States, in a wide range of areas. There were concerns about what would happen with enslaved people who were forced to labor in tropical heat in the American South. There was concern about what would happen to settlers, especially those coming from the northeastern United States, who moved into the warmer climates of the Mississippi Valley. And there was concern about soldiers in the Union Army who had to fight in summer heat in the South during the Civil War. Mortality during summer heat waves likely happened throughout the 19th century, but you don't see much discussion of it. And the assumption now is that the heat that must have killed people was, or the mortality from these heat waves was likely obscured by summer outbreaks of dysentery or cholera. And so there were many causes of increased mortality every summer, especially in cities, not just heat, but also diarrheal illnesses. And so historical demographers suspect that was the signal from diarrheal diseases that dwarfed what must have been happening with heat-related mortality. Now, if you go back to the medical literature, which is now easier than ever to do, you can find accounts of heat waves. There was a prominent heat wave in Boston in 1892 that led to case series being published by physicians at MGH and Boston Medical Center. A major heat wave struck the Midwestern United States in 1901, and nearly 10,000 people died. There's another heat wave in Boston in 1911. And you'll start to see the statisticians who are writing this up starting to use more recognizable language. For instance, they would say in this 1911 heat wave, for the week ending on July 15th, there were 394 deaths compared to only 221 deaths the year before, suggesting that there was some amount of excess mortality caused by this heat. And if you look at these early work, you can see again many issues that are recognizable to people now. One was concern about the danger of urban environments. What we now know as the urban heat island effect had first been described in England and Germany in the early 19th century. As soon as there was coal-powered industrialization, people recognized that these cities were starting to create their own microclimates that were characterized by higher heat than you'd see in rural areas. You'd see epidemiologists and statisticians complaining about the quality of the data. They weren't sure exactly what to count. Should you count cases of heat stroke, heat-related deaths, excess deaths? There were many different measures that you could use, and it wasn't clear, they weren't sure which ones were the right ones. And they were also interested in these questions of who was at risk. And so in the early reports, you'll see discussions of laborers who are working in confined spaces, especially in factories or in sugar refineries. Recent immigrants coming to the US from Northern Europe were seen to be at high risk. And there was recognition that impoverished populations, for a variety of reasons, seem to be higher risk as well. One of the basic challenges that came up was this question of how do you get good data and how do you deal with standardized case definitions? And so one of the first serious analyses found of heat in the United States actually came from a team here at Harvard. Margaret Hilferty, who was in the Department of Vital Statistics at Harvard School of Public Health, teamed up with George Shattuck, who was assistant professor of tropical medicine at Harvard Medical School. And they published a series of 3 articles in the 1930s. The first about the problem of sunstroke in general, the second about the Boston heat wave of 1911, and the third about their effort to understand the global experiences with heat. And they struggled with many different kinds of problems. How do you find reliable systematic data? How do you achieve consensus about standard case definitions? They were really frustrated with the quality of the data that they felt prevented them from producing definitive analyses. And you can still see these arguments about case definitions cropping up in various contexts recently. So for instance, the Centers for Disease Control makes a concerted effort to get heat-related data released more quickly. But every time there's a significant report of heat-related mortality, someone challenges the data. One of the most striking accounts of this occurred in 1995 in Chicago, when there were reportedly 700 deaths from a heat wave in July of that year. The mayor was quite angry with the medical examiner and thought that the medical examiner was using too permissive criteria of what counted as a heat-related death. As Mayor Daley said, according to the medical examiner's criteria, everyone in the summer that dies will die of heat. And this is something that is a recurring problem for efforts to sort this out. Hilferty and Shattuck, especially when they looked at their global data, were also puzzled by what they saw as a seemingly random distribution of heat-related mortality, both in tropical areas and in temperate areas. So for instance, the data they could find showed that there was high heat-related mortality in Panama, but very low in what's now in Sri Lanka. Heat was a terrible problem for British soldiers in India, but it didn't seem to affect French soldiers in Algeria. And they were really puzzled by these inconsistencies. They weren't sure if it was a problem with the data, whether the differences were explained by different customs and practices. The French military said that they just had better measures in place than the British did to deal with the heat, and that's why the French weren't dying in the same way that the British were. And everyone concluded, of course, that more research was needed, because researchers always conclude that. The US was struck again by severe heat in the 1930s. The heat waves don't get nearly as much attention as the Dust Bowl, but these were related phenomena, with the heat contributing to the droughts that led to the Dust Bowl. But the estimates are between 1930 and 1936, there were 15,000 heat-related deaths in the United States. nearly 5,000 of those in 1936 alone. And you'll see a lot of editorials in the medical literature commenting about this. This one is from the New England Journal of Medicine, extreme heat versus human beings. And the basic conclusion they drew was that humans were attuned to temperate climates and cannot tolerate prolonged exposure to heat. The experience with the Dust Bowl and the high heat mortality in the 1930s prompted and enabled another important analysis by Mary Gover, a statistician with the US Public Health Service. She looked at US census data from 86 cities from 1934 to 1936, and then drew weather data from or temperature data from the US Weather Bureau. And what she did is she focused not on the absolute temperature in any particular city, but on how much the temperature during the heat wave in that city deviated from the typical conditions in that city. So she was looking at a deviation from normal temperature to see if that's what correlated with mortality. And that was the effect that she saw. And the other thing that she had observed was that if a city experienced a second heat wave in the same summer, the mortality from that second heat wave was much lower. And she saw two possible explanations for that. One was acclimatization, that people had gotten accustomed to heat during the first heat wave, so that when the second heat wave came, even if it was of the same intensity, it was less disruptive. And then the other explanation was a more pessimistic one, which is that everyone who was vulnerable to heat died in the first heat wave, and so there were fewer vulnerable people left when the second heat wave had come. And as I'll say in a minute, researchers continue to study both of these possible mechanisms today. And then the study that followed soon thereafter in the late 1940s suggested a different mechanism. And so this was a study of New York City nursing homes. And there'd been a heat wave in 1937 that had killed 8 residents of one nursing home. And the staff who were shocked by this implemented a system of monitoring, prophylaxis, and treatment. And what they observed, and then wrote up in the New England Journal of Medicine, was that when a much more severe heat wave struck in 1948, this time no one died. And this, for them, was a hopeful prospect, that it was possible that the effects of heat could be managed if you took proper precautions. And so one thing that they did is they paid close attention to how much patients were sweating. And if they noticed decreased sweating in any patients, they would intervene aggressively to rehydrate and cool these patients to try to head off mechanisms of heat stroke. And again, one of the things that you see in this literature that really starts to proliferate in the 1940s and the 1950s is this persistent interest in this question of who was at risk. As I mentioned earlier, a lot of the attention in the 19th century and early 20th century had focused on people who had to exert themselves in hot places, laborers and soldiers especially. You also see recurring concern about alcohol use. You can see this in an article by Palfrey in 1911, and then Hilferty and Shattuck in 1938, where they were describing higher mortality in people who were described as inebriates. And then there was also persistent interest in questions of race. And one of the things that's interesting about race is you see an inversion of the discussion of who was most at risk. And so in the 19th century into the mid-20th century, the feeling was that it was Northern Europeans who were most at risk. And so in a very early account from 1864, in the Boston Medical Surgical Journal, the author described how people who came to Boston from Northern Europe, their skins are too thick and sluggish for the high and variable temperature that you see in Boston. When Shattuck and Hilferty published their review of the 1911 heat wave in Boston, they were struck by the apparent vulnerability of the Irish-born, with a difference of mortality rates of 153 per 100,000 for the Irish, but just 22 per 100,000 for people who were born elsewhere. So a 7-fold difference in mortality. They weren't sure exactly about the mechanism. They wondered whether this was a racial issue and that the Irish were adapted to life in cold, damp Ireland and couldn't tolerate the balmy climate of Boston. They were also aware that many Irish immigrants often had to do hard work as laborers. And then they also perpetuated the cultural stereotype that there were high rates of alcoholism amongst the Irish. But they were also puzzled to see high rates in what they described as colored people, descendants of people from Africa, who were generally assumed to be racially less susceptible because they had evolved in a tropical country. And Hilferty and Chaddock suggest that maybe those colored people had had higher exposure to dangerous conditions, and that's how you could explain their high mortality despite their racial protections. And these kinds of heat waves in these analyses received steady attention after World War II. Researchers began to benefit from the advent of high-speed computers and better statistical methods. And you start to see more sophisticated analyses. So in 1970, there was a report published about heat waves in Los Angeles, which found excess mortality during 3 heat waves, 1939, 55, and 63. And one of the things that struck the authors was that the mortality was much lower than expected in 1963, based on how hot it was. And they suspected that this was evidence of the protective power of air conditioning. And it turns out the 1963 heat wave in Los Angeles saw record levels of electricity use in the city, which is exactly the same thing we're seeing this week with a California heat wave, shattering records for both heat and electricity use. But by the 1960s and 1970s, researchers were increasingly concerned that air conditioning represented a Faustian bargain. And there were a series of concerns about this. One was that if people had access to air conditioning, they would not acclimate to heat each summer, and so that their risk would remain high throughout the summer, and they didn't think that was good. And then it was also an issue of environmental justice. Air conditioning reduces heat for the users, but it does so by pumping the heat and the humidity into the outside environment, increasing the risk for the people who don't have access to air conditioning. And the fear was that this would increase heat-related mortality for people with low socioeconomic status, even as it decreased heat-related mortality for those wealthy enough to afford air conditioning. There were severe heat waves struck in 1966. 1,000 people died in New York City alone. And here you start to see shifting understanding of the risk groups. In 1966, the problem was not young adult laborers, but the elderly population. And so the reports describe high rates in several different groups, high mortality in the non-white population. And this triggered arguments about whether this was about race, about poor housing, about crowding, poverty, or ill health. Researchers also recognized various indirect effects of heat. There was increases in urban violence were associated with heat waves. And that led researchers to say we should not call this an urban heat island, but an urban death island instead. And you can see continuing efforts to try to create models to predict how high mortality would be given for a different, given a specific temperature. And if you look at this attempt to figure out the temperature mortality ratio, the inputs are temperature, population density, and income of the neighborhood. Another heat wave in 1980 shattered records. This was initially reported by the CDC as causing 1,265 deaths, but this estimate was later revised up to 10,000 deaths from heat in 1980. Researchers at the CDC published a whole series of studies. In the initial reports, they focused on risk factors like age, poverty, non-white race, and pre-existing conditions. But they also sent researchers out into the community to do questionnaires. And they celebrated this as the first example of shoe leather epidemiology applied to heat-related mortality. And so they did a study of 156 victims of heat stroke with 462 controls. And this allowed them to identify a new set of risk factors: access to shade, ability to care for yourself, and then protective factors, things like increased fluid intake. They also collected testimony, really tragic testimony, from people who had lived in these neighborhoods. And there was one account from Memphis of elderly residents who were afraid to open their windows because of crime in the neighborhood and refused to turn on their air conditioning because they couldn't afford their electricity bills. These kinds of reports prompted several rounds of hearings in the US Senate. And as one senator commented in 1983, to think that people died from heat prostration because of overwhelming fear of an electric bill is simply shocking. but that had indeed happened in Memphis and other places. The recurring mortality, 1966, 1980, and other years, led researchers to criticize public health officials for their failure to take action. You start to see researchers saying, look, we know exactly who is at risk. We know what needs to be done to protect them. And their continuing deaths reveal our failure to anticipate and prevent the mortality that we know is going to happen. We need to give more attention to urban, poor, elderly people, especially those with pre-existing conditions and those without access to air conditioning. At hearings in 1983 about what had happened in 1980, senators described being appalled by the lack of preparation. They believe that this happened because local officials lacked knowledge of their risks. And that if these local officials simply knew that heat waves happened, then they would be better able to be prepared. And so in response to this, what you'll see is the CDC makes a concerted effort to improve knowledge amongst public health officials about the risk of heat-related mortality. And so in most years in the 1980s, the Morbidity and Mortality Weekly Report, usually in June or early July, would publish a review of heat-related mortality. And typically they would say, last summer, this many people died. They would usually give a few case studies as examples of the heat-related mortality. They would remind the readers who was at risk, and they would remind people of the very familiar preventive strategies, warnings, access to air conditioning, access to cooling centers. And so, for instance, in this report, typical report published in late June 1995, the CDC said this kind of mortality should be readily preventable. And in really a tragic irony, this was published on June 30th. 2 weeks later, the Chicago heat wave strikes, killing 700 people. And so even though the CDC had said recently this should be totally preventable, Chicago officials catastrophically failed to prevent what happened. Again, this heat wave produced some really shocking comments from officials, not just Mayor Daley, who accused the medical examiner of having too permissive an inclusion criteria, but the deputy commissioner of public health for the city, John Wilhelm, said, "What we've not appreciated before is that heat can kill," which is really a stunning comment for someone to make in 1995. As I've reviewed, there are accounts going back to the Old Testament of heat being able to kill people. By 1995, the CDC had probably published 20 bulletins in the MMWR about the ability of heat to kill people. And yet, at least in a public statement, a deputy commissioner of public health for the third largest city in the United States can claim that he had no idea that this kind of thing could happen. It's really stunning. The experiences of Chicago prompted the CDC and many other researchers to do very detailed studies of who was at risk during this heat wave. And so the CDC sent out the Epidemiology Intelligence Service, and they did a case control study of residents of Chicago and identified the two key risk factors they identified were social isolation and people who were confined to bed. And so when they published this article in summer of 1996, this is when I was paying attention to heat in graduate school. And so I wrote a letter to the editor, which much to my surprise was published by the journal, asking the authors why they didn't talk about race and poverty, which had been the two recurring risk factors described in the literature going back decades. And they really copped out. They said because of the design of their case control study and the neighborhood structure of their sampling, their data did not allow them to talk about either race or poverty, which is why both of those things were invisible in their analyses. Another graduate student at the time, sociologist Eric Klinenberg, got interested in this and published a very extensive study, which became an award-winning book coming out of his dissertation, what he described as a social autopsy of the Chicago heat wave, which sought to denaturalize the disaster. He concluded that the heat wave was a structurally determined catastrophe, something that we should have seen coming, should have seen how to prevent it, but for a variety of understandable and regrettable reasons, it was not prevented. And so he cast a wide net of blame, really laying into the city officials, the media, public health department, and it identified a wide range of risk factors, poverty, isolation, degradation of the quality of public housing, and also specific cuts to social services that the city of Chicago had made in the 1990s. But as often happens, when a young scholar publishes work that gets a lot of publicity, other scholars totally tore into Klinenberg's work, especially another sociologist, Dunier, who had trained in University of Chicago, but was by then on the faculty at Princeton. And he accused Klinenberg of being guilty of the ecological fallacy, which you're all familiar with, and says Klinenberg ascribes attributes of the neighborhood to all the individuals who lived in it, instead of stopping to see what happened with each of these different individuals. Dunier hires a couple graduate students. They do about 2 days of field work, interview some of their survivors, and concluded that many of the people who died actually hadn't lived alone. They had lived with families. And then the problem was that many of them drank too much alcohol, to which Klinenberg responded that Dunier was basically blaming the victims for their own deaths, and that this emphasis on how much alcohol they drank or did not drink was part of a war on the poor. One of the other critiques, instead of just bickering with Klinenberg about methods, actually offered its own analysis of what had happened, drawing on much more elaborate social theory and epidemiological theory, and again identifies a related but distinct set of risk factors: neighborhood structural disadvantage, social network interactions, and collective efficacy, the kinds of concepts that were being developed by people in social behavioral sciences at this time. And they found that the strongest predictor of mortality was regions of the city that had undergone commercial decline over recent decades. And then meanwhile, not surprisingly, both affluence and collective efficacy were protective against heat-related mortality. Despite this increasing resolution with which we understood heat-related mortality, the problem continued to recur. I suspect Bert remembers this well, but a far deadlier heat wave struck Europe in 2003. There were 70,000 deaths overall in Europe, half of them in France, over 15,000 deaths in Paris. A French historian at the University of Wisconsin, Richard Keller, published a fascinating account of what happened. His analysis was really focused on the deaths of poor, isolated, elderly Parisians who were put at particular risk because of interesting details of Parisian apartments. Many of these people lived in what had been designed as the servants' quarters for the beautiful mansions that face the boulevards of Paris. And so you had these people who were living in the 7th story back corner apartment underneath copper and tin roofs with no ventilation, who are extremely vulnerable in this heat wave. But again, every time someone published an analysis saying, here's what the problem was, there were furious critiques that were published in response. This analysis said, well, if you actually look at the people who died, yes, there were high mortality rates of isolated elderly living in these small apartments, but most of the people who died actually died in different circumstances. They died in nursing homes, and especially people who required assistance with their daily activities. And they used a dependency scale to measure how dependent people were and showed that mortality correlated with dependency. This suggests a different set of risk factors, not isolated elderly, but institutionalized people, especially people with comorbidity. And again, a different set of system failures and a different set of possible interventions. And again, this focus on nursing homes would be familiar to anyone who's been paying attention to what happened during COVID, where again, a very high share of the COVID mortality, disproportionate share in the United States, again, took place in nursing homes. And the French heat wave refocused attention on an old question. Were heat waves actually simply killing vulnerable people who were on death's door anyway? Not so much killing people as hastening the imminent deaths of vulnerable people. So for instance, you'll see this letter from a group in Lyon from 2003 saying their sense was that the heat wave accelerated death without actually affecting annual mortality. This has long been investigated and debated by epidemiologists going under different names. Some refer to it as anticipation or displacement or harvesting. You can see this in the discussions of the 1966 heat waves. One report from the American Journal of Public Health thought that there was no evidence of displacement or harvesting in St. Louis, but another report about New York City in 1966, if you look at those graphs, it looks like maybe there was some harvesting, with mortality being lower after the heat wave than it was beforehand. But you also see this dip immediately before the heat wave. So it's very hard to interpret a graph like this just by eyeballing it. One analysis claimed that there clearly was displacement in this 1966 mortality, but turns out this analysis was written by a guy who's notorious for being a climate denier. And so he's trying to minimize the impact of global warming. And so I did a cursory review here. There are many people in this department who have more expertise here, but the conclusions about anticipation, displacement, and harvesting are really all over the map. And so you'll find reports like this one in 1993 from Lancet by Kalkstein, which found significant displacement in New York City, but not in St. Louis. Another one found evidence of displacement in London, but not in Delhi. Kaiser and Joel Schwartz found 26% displacement overall, but you did not see evidence of displacement in African Americans who are at higher risk of heat-related mortality. Another study of the French heat wave found that of 3,000 excess deaths, only 253 could be attributed to harvesting. Another study showing that harvesting was more pronounced in Northern Europe versus Southern Europe, more pronounced with mild heat waves than severe heat waves. More recently, in 2017, someone said, yes, the deaths are displaced, but they're displaced by more than a year. But that raises a different question. There are many methodological reasons why it has been so hard to pin down this displacement effect. There's this question of time horizon. Are you looking at displacement over a week, a month, or a year? The longer the time horizon, the more accurate your assessment, but the more exposed you are to other factors. So for instance, if you're looking at displacement over the year that follows a heat wave, you have to deal with the confounding effects of things like the annual flu season, which varies a lot from one year to the next. And then the basic concept itself has been criticized. So Keller, the historian who wrote an analysis of the French heat wave, saw the political stakes of these arguments. He said the harvesting concept is more exculpatory than explanatory, amounting to a dismissal of life on the margins than a clear picture of the disaster's effects on mortality. So he was concerned that anytime anyone said, oh, the heat-related mortality is just displaced, they were saying, therefore, it doesn't matter. These people were all about to die anyway, so we don't need to worry about them. There's been one niche issue that has been of an enduring interest, and again, of local relevance because of the characters involved, and that's been efforts to figure out the relative importance of air pollution and heat causing mortality. So starting in the 1970s, a series of studies by epidemiologists in California concluded that air pollution actually was not a significant effect of mortality. And so this guy Ellis, who wrote one of the best reviews, concluded that excessive heat is much more lethal than high levels of air pollution. And in fact, he worried that if public health officials told people to decrease electricity use in order to reduce air pollution, that would actually increase heat-related mortality. Writing in 1993, Kalkstein contrasts his own work to that of Joel Schwartz and Doug Dockery on Los Angeles. And Kalkstein concludes that our work indicates that daily mortality fluctuations are much more sensitive to weather than to pollution concentrations in 10 US cities. I'm going to talk to Joel more about this on Friday, but my feeling is that Schwartz and Dockery eventually won this debate. If you look at global estimates, now the best guess is that 90,000 people die a year from heat and 8 million people are dying a year from air pollution. So it looks like with the benefit of hindsight, Joel and Doug were right about this one. Then I want to finish with one last issue, this issue of global warming and changing notions of responsibility. Now, humans have long seen ourselves as victims of the weather. We all love to complain about it, and you'll see this in the medical literature as well. And so in 1972, there was an editorial or an op-ed in JAMA that said, to a large extent, we are truly at the mercy of the elements. But we've known for quite some time that that's not quite true. As I said earlier, the urban heat island effect was recognized in the 19th century. we have created part of the problem of urban heat mortality. And second, we have known with increasing precision who is most at risk. And so public health authorities have long argued that we have a responsibility to intervene on those people who are at risk to try to help them dodge the predictable mortality associated with heat waves. And of course, our notions of responsibility become even more profound with the advent of global warming. The greenhouse effect itself was first proposed in the 19th century. 1957, Roger Revelle, who would later come to Harvard, described how humans were carrying out a large-scale geophysical experiment by pumping carbon dioxide into the atmosphere. But even into the 1970s, leading climate scientists remained very skeptical about the reality of global warming. This changes over the 1970s and 1980s when a series of groups, National Academy of Sciences, EPA, World Meteorological Organization, released a series of reports with growing urgency. And so in 1986, when James Hansen famously testified in the US Senate that he expected there to be measurable warming within 5 to 15 years, so by the year 2000, the Senate requested a full investigation of the global warming by the EPA. And the EPA issued its report in 1989, which issued a very dire warning that global warming would cause severe disruptions to human societies. Mortality would increase from many mechanisms, most obviously from heat-related mortality. Now, as part of this analysis, Kalkstein attempted to create predictive equations. As he described, this was really complicated. Different cities had different threshold temperatures at which mortality from heat starts to increase. It was very difficult to predict the effect of acclimatization. How well would humans respond to these rising heats? But with those caveats, he predicted that annual mortality in 15 major cities would increase from 1,000 per year in the 1980s and 1990s to over 7,500 a year by later this century. And since the 1990s, there's been a steady drumbeat of warnings in the medical and public health literature, including calls, these ones from McMichael in the American Journal of Epidemiology, and then elsewhere in the 1990s, saying not just would warming cause serious problems, but that it raised many difficult methodological issues for epidemiologists. The links between heat and mortality are complex and indirect. They're not well suited to typical epidemiological methods. Epidemiologists needed to develop new methods to handle uncertainty, and also new mechanisms for communicating the complexity and uncertainty of this topic to an interested public. So as I said, I first began thinking about this in 1996 in the midst of this, in the aftermath of the Chicago heat wave. And I had wondered at the time whether this new appreciation of our responsibility for global warming would motivate a response. You know, when I was a young cynical graduate student at the time, and said, you know, without any clear mechanisms of global governance, it wasn't clear how any of this would happen. And when I wrote my letter to the New England Journal of Medicine in 1996 about the CDC analysis of the Chicago heat wave, I said, how come you didn't mention global warming at all in the analysis? And the authors chose not to respond to that question. Only in the mid to late 2000s do you start to see the annual reports in the MMWR begin to mention the threat of global warming consistently. So even though the EPA was very concerned about this by the 1980s, the CDC only picks up the crusade in the 2000s. But now you do see serious attention. 2016, they released this glossy report on climate change and extreme heat. So the extreme heat events in the United States are already occurring and expected to become more common, more severe, and longer lasting as our climate changes. So what are the key issues now? There are a whole bunch of them. Geographic patterns are still a puzzle. For most of the 20th century, the focus was on mid-latitude cities, places like New York or Shanghai, where heat was infrequent and heat-related mortality were seen to be very severe. And so on these maps, these are from the 1930s, you can see the big cluster of heat-related mortality on the Atlantic seaboard in the Northeast. But if you look at the most recent data from the CDC, most of the heat-related mortality in the US is actually occurring across the South and Southwest. So Arizona, California, and Texas, which represent 23% of the US population, represent 37% of the excess deaths from heat waves. So this is a case of the hottest states having the highest mortality. Race justice regrettably and not surprisingly, is still a major concern about this. Many recent studies have shown links between real estate policy and mortgage redlining going back to the 1930s, having a measurable signal in exposure to heat and excess heat-related mortality today. Poor and minority populations in the United States remain both at highest risk of heat and also least likely to have access to air conditioning. There's been concern about that from the 1960s, and the problem hasn't yet been solved. This is even more extreme and dramatic on a global scale. You'll see op-eds or editorials like this recent one from the Washington Post. Countries in Africa, which are responsible for only 3% of global carbon dioxide emissions historically, face a 118-fold increase, not 118%, but a 118-fold increase in exposure to deadly heat in the coming decades. So how worried should we be? Like with many things in life, you could spin these numbers to both an optimistic and a pessimistic scenario. So the optimist might say, well, look, if you look at the CDC reports, mortality has been increasing from the 1980s, increasing faster than population growth, shown in brackets. And some people will say, the official counts are a 90% underestimate. But even if we're at the situation where it's 7,000 deaths a year, that's relatively low on causes of mortality in the United States, compared to 600,000 deaths a year from heart disease, 400,000 deaths from cancer, 200,000 deaths from COVID. Heat-related mortality, even a much larger number, 7,000, wouldn't make the top 20 list of causes of death in this country. And the country seems to have survived record heat this summer without dramatic mortality. So that's either what an optimist might think or what the fossil fuel industry might say. But then there are the pessimists. Numbers are increasing faster than population growth. There have been episodes with high mortality, like the 70,000 who died in Europe in 2003. And also global populations are aging. So more people are now in the higher risk groups when heat-related mortality or when heat waves strike. There are also growing concerns about the wet bulb temperature. If anyone's interested, this video on GRIST is a terrific explanation of what goes on here. But if the combination of heat and humidity hits a wet bulb temperature of 95, human bodies are unable to radiate the heat we generate as part of our routine metabolism. And so physiologists predict that when the wet bulb hits 95, high mortality will follow within 24 hours. There have been 14 times so far in measured meteorological history in which the wet bulb temperature has been hit, mostly in the Arabian Peninsula and in Pakistan. This is expected to become more common, and if it happens, parts of this Earth might become uninhabitable because of heat. I don't know if any of you have read Ministry of the Future. This was a recent climate thriller that got a lot of attention. This book leads off with a heat wave in Uttar Pradesh in India, where the wet bulb temperature is hit and 20 million people die. It's a frightening scenario, but it's a plausible scenario. And then in the story, this becomes the first of global crises that leads to a binge of global re-engineering to save the human species. So where do things stand? Global warming and its likely effects are very well documented now. We know that we could reform the energy economy to stop and then reverse climate crisis. We haven't done that yet. We're making progress, but we have a long way to go. It could be that we will have the potential to acclimatize to rising heat and implement measures that prevent mortality. It's not clear if we will have the wisdom and wherewithal to do that, and if we do so, if it will benefit all populations, not just the wealthy. And then the other question is, will we make any of these changes before a mass mortality event happens? And so there's this question of, which future will be ours? And if you want that question answered, you should ask someone other than a historian. And I'll just leave you, take questions as this graphic unfolds. But this is one of the terrific charts of rising temperatures over the 20th century that, as you can imagine, gets more dramatic as time goes on. So thank you, and I look forward to hearing all of your thoughts. I suspect there are people here who have worked on this, and I'm really interested in hearing what all of you think. Thank you.